Many uncatalyzed reactions are slow under physiological conditions. One of the most striking characteristics of enzymes is their catalytic power, which is the ratio of the catalyzed reaction rate constant, Kcat, to the uncatalyzed reaction rate constant, which is K oncat. I know, terminology is so confusing. Yeah. So the one with the catalyst, cat. The one without the catalyst, uncat. Okay, so the reaction catalyzed by the enzyme A has an uncatalyzed reaction rate constant of 0.1 per second. Use the graphs to calculate the catalytic power of enzymes A and B. Okay, so we'll look at the graph. This is K with catalyst, right? We know K without catalyst because that's that number right there, right? Okay. And so catalytic power of enzyme A at pH 7. So we look at pH 7 on the graph, we would trace it over, and that's about 500,000, right? So what is the catalytic power of this enzyme at pH 7? Well, we take 500,000. 500,000 would be what? Is it? Try it. What's the scientific number for 500,000? How many zeros are there? 1, 2, 3, 4, 5. So it's not just the number of zeros, is it? See, that's 10 to the 6th. My. So are we just comparing it to 0 or 1? We're not comparing it to 1, right? We need to compare it to the uncatalyzed reaction. The uncatalyzed reaction is 1/10. So we take Kcat, which is 500,000, divided by 1/10, right? Or 0.1. And that would give us 10 to the 6th, wouldn't it? So that would be 5 times 10 to the 6th, or 5 million, right? Okay. I know, right? Ooh. Yeah. So always remember that these are ratios, okay? The catalytic power is always a ratio. Because does it make sense to say, like, I improved, so like if you're looking at, I improved profits, do you, well, then compare those profits to, of like, I improved Microsoft's profits by comparing their profits to a deli down the street? No, right? That'd be silly. Yeah. You have to compare it to something, right? It's a relative number. Okay, and then we do B here, the catalytic power of enzyme B. And right here we have a log 10 scale, and we have uncatalyzed right there and catalyzed right there. So it's always a ratio between the uncatalyzed and catalyzed, right? So we take the uncatalyzed, that's what? Well, first off, what does this mean? Log of. This is 10 to these powers, right? This is the powers right here. Okay. And so this would be 10 to the what? Yep, about 8, right? And this one would be 10 to the 1, yeah. And so it's like a 10 to the 1 over 10 to the negative 8, which would be 10 to the 9th, right? Is that making sense so far? Am I confusing anyone? Okay, good. It's very easy for me to confuse people. So if I'm not, we're doing great. All right. I guess that's that.